Okay guys, I'm getting ready to go on a trip and I got more failed GM bus door rubber. And I've talked before about how I've 3D printed some reinforcement for this rubber hinges, and I'm getting ready to make some more. These pieces are about 2 inches long. Before I printed them like 4 inches long, and it's like printing a piece of spaghetti because it's flexible rubber and it's going up in the air, and it's very tricky to print a long piece of it. So I'm going to print 4 of them right next to each other, and I'm going to, I can just stick them in there next to each other if I want a longer piece. I've got 2 doors that I need to replace rubber on, and I want to put this on each end of the door is what I'm thinking. So I'm going to do 4 pieces of it, and let's see what this looks like here. So TPU with a 0.8 nozzle is what I use. And there's the preview. It says it's going to take 1 hour and 1 minute to print, and it's going to use $1.18 worth of material. So I'll go ahead and get this going here. Okay, this is the 3D printer that I built from an open source kit. The bed is heated up to 90 degrees Celsius, and the nozzle is heating to 200 degrees Celsius right now. As soon as that hits that, it's going to start printing, and I have to watch and make sure that it doesn't destroy itself in the process. You can see the nozzle starting to drip there, and I'm going to catch that and cut it off so it doesn't make a mess in the bed there. And I have to be ready to shut it off in case anything goes awry. It's going to start any second here. This black material coming on the top here, this is the filament, that's the TPU that I'm using to print that. $183, $87, $195, almost there. This has a glass build plate with Gecko Tech adhesion material on it. It's a 300 by 300 millimeters. It's going to home the bed. I have to get this off of here. A little goober. As soon as it goes here, it's going to seek to this corner. This little pad here. It's finding that corner, the height. This little inductive thing here is finding the corner. And it's going to go do that at each corner. This is the bed leveling algorithm, basically. I have to make sure this doesn't fail, because sometimes it fails and goes beyond. There it goes, it's good. So now it's laying down the first layer. It's just starting to extrude, and this is just to kind of get the flow started and started to stick to the bed. Sorry if it's too bright. Let's see if I can make it a little easier to see there. So these first layers that it's laying down are the purpose of this layer is to provide a bed that the parts are going to be printed on and adhere nicely. And so it's printing them very slowly, and it's kind of spooging that material into there, mashing it down. It'll be moving much faster after this first layer happens here. Yeah, and that, I don't even know if you can tell on the camera, but that is like super thin compared to the other layers. It's meshing it really, really far down in there. The other ones kind of, the other layers kind of stick up, and those ones are mashed down in there. And it's probably a little hot. It's kind of bubbly. The material coming out of there is kind of bubbly because it's a little too hot. Because the temperature is calibrated for the speed that it's going to be printing at here when it actually starts making the part. Or parts. These first few layers are really critical for the success of the print. Finding the corners of the bed is critical because it uses that to calculate kind of a software leveling, because the nozzle gets so close to the bed that it has to compute where that plane lies in order for it to be able to do that. Or you have to get your machinist tools out and make sure the bed is level across the travel in all directions. So, I mean, I use machinist tools to get the bed level, but after that, you know, it is subject to flex and heating and distortion and stuff. So it's the bed leveling is a nice feature to have. So I'm going to go ahead and stop recording right now, and I'll pick it back up here when it gets more interesting, because it's just building this first few layers right now. I don't know if you can see, but what it's spooging out now is a considerably thicker layer than the ones that it laid down earlier. And it's putting them right on top of those thin ones that it smushed into the bed. Now I'm printing this with a fairly thick nozzle, a 0.8 millimeter nozzle. That's pretty large as far as 3D printing is concerned. Most guys are probably doing something like a 0.2, maybe a 0.35 or a 0.4. But I am not concerned about detail on these parts. It is more about speed and flexibility. So I guess I'll go ahead and continue recording here, because it's going to shift here to a different pattern in a second, I think. So now it's going across in a diagonal, and it's building a base to print those parts on. This is a layer that will kind of peel off. So I'll go ahead and stop recording now, and I'll pick it up here when it actually starts making the parts. Okay, it's just about done with that layer. So now it's starting to lay out the part outline on top of that. This is this thing that it's printing on top of is called a raft, because the parts float on top of it. And these parts are tall and skinny, and so without this support structure, they would flex when printing, and they wouldn't adhere to the bed properly, so that's why you do a raft. If you have a part that's got a large flat surface on the bottom, it's not always necessary to do this. I don't know if you can see the part outlined there. It's already starting to take shape there. So it's just going to keep doing that until the parts are 2 inches tall, and then it'll stop. Here's a little progress shot. So I will have to cut off the stringers between the parts. There, where it's goobered in between them. It's not a big deal. I'll cut off a pair of clippers or utility knife, no problem. Check on the progress on my print. It's going. It's getting there. The door rubbers are failing here. It's been going on for a while, and it's just ripping enough now to where I don't know if I want to be taking a chance on that. This one's worse on the big door. This has been a problem. I tried to fabricate a hinge for that. Didn't work out. This one's failing in multiple places here. So there, there, And the annoying thing is I just replaced these probably, oh, I don't know, it's probably been a year, but still, that's unacceptable. Here's one of my 3D printed hinge reinforcements right here. You can't really tell, it's, you know, this is the regular door rubber here, and that's the TPU printed hinge. So I'm going to try a couple 2-inch pieces of that on this door and this door as well. This one gets used a lot. This is the one that has the power and water hoses in it and stuff, so you're getting into this one a lot and needs to be solid. So we'll know in short order if that's helped. He's going to comment on my video like, well, why don't you use the stainless steel hinges? Well, this is why. Here's one of the stainless steel hinges that are now unobtainium because the guy that was making them passed away. But you see the difference in thickness? This is the door rubber that everybody gets from Luke. See the difference in the thickness there? So you cannot have this installed in the track at the same time as this. And this will not stretch enough to compensate for this gap. It's really annoying. I've been down this road before. Now, if you just wanted to run the hinges by themselves and then put something else in there, you could do that. Some guys have done that. But these hinges are also a water seal. They keep the rain out from getting in your bay and getting into your floorboards there, because that's right where the wood is, in the floor of the bus. So I like to have a watertight seal there. So yeah, I'm not running these hinges. I've got a couple of them around here I might consider selling. But yeah, that's why. Okay, my print's done now. See if I can just pull this off of here. That's how it comes off. Now I just got to trim this up. These just tear off this base, but I can't do it one-handed. Okay, there's the finished product. I just spent about 20 minutes cleaning those things up. They just got to be clean enough to slide into the track, really. The only part anybody's going to see is this part here, and probably not much of that. So it's getting late. I'm going to install them tomorrow. I don't anticipate any problems. Oh, and I could have made these longer. This is my first time printing a group of 4 of them. Before I just printed 2. And I think printing 4 of them, I could have got away with going taller. Probably 3 inches, maybe 4. I don't know. Could be worth a shot, huh? Gotta open it up and take the shock out. Okay, this is going to get heavy on you.
Okay.
Probably got to lift it up a little bit more. Okay, hold on. Down just a little bit. Let me just kind of do it with my shoulders. There we go. All right. And then, you got it? Okay. And then I got to get this thing out of the way. I'm going to have to take the bottom off. Okay, Now we gotta cut it. Let the door down. We're gonna latch it. We're gonna get the utility knife. And I don't think it's gonna go anywhere. It's already ripped all the way to here. There's additional rips in it. But what I'm looking for when I cut this is, you know, basically the top of the door on the inside, right? Because there's a inside lip there, and I'm just gonna run my knife along that edge. And I don't want to scratch the paint, so I gotta be careful. Control it. All right, now we gotta take the screws out. I usually use a power tool for this.
Your power tools inside.
I don't know.
Oh, just do it. Okay. What are you gonna do with this hinge here?
We're gonna take it out. It'll slide out when we take the rubber out. There's no screws down here?
I couldn't see any. Nope. There's a hole but no screw.
Okay, well maybe we can find some screws to stick in there. All right, we need that. Pull this out, and we're gonna pull it out of the other one too. But grabbing this with a pair of needle nose is sometimes easier.
Do you want me to go get needle nose?
Nope, because they're just right here. Should be. Ah!
Okay.
Blood sacrifice. Not quite. Just kidding. Close.
Now will we be putting that hinge back in?
We're gonna put that rubber in there instead.
Okay.
There's some rubber stuck in there. Right there on the end, you see it? Yeah, you can use your fingers to slide it out. Okay, do the door.
Well, I didn't want to get it on the thing you said, so I squirted on this.
Yeah, but you can like this. And squirt it in there. Oh, don't splatter it on our brand new.
Gross.
Yeah, it's full of crud. Does it need more?
No, I don't think so. But it's just like, ugh.
That's a pretty tight fit. Okay. Need some pliers.
Maybe some?
Yeah. Oh, wait.
Okay.
Go ahead. I want to rip it, so just go gently. So we don't tear it when we're feeding it in there. Oh boy, there's a big gap in there. How's there such a big gap?
You should have measured it through here.
Well, let's bring these in just a little bit. That was too much. All right, let's try that. Okay, now we gotta wrestle this big. Oh, you're gonna stick the screws in, right?
Yeah, warm.
Especially in here. So how many did you
Only
find?
two.
Two in this?
Uh-huh.
So where are they gonna end up?
These two were in the middle area.
Should try and find a couple more. Let me see one of those. I'm not gonna look and see what I got hardware wise.
Uh-huh.
Lift it up a little bit more angle. Like that. It's gotta come up on this a little bit. Hold on, back it up, back it up. I gotta get it started on this other one properly. Okay, it's just barely started. Keep your end level with, there you go. Try and do this without scratching it out of the paint.
I
The
am.
trick is to pull out here. We're doing this without any lube. We might need some though, it's getting harder for me to pull. Okay, so where's our scope? So, just a little bit of Dawn. I don't really want to put it on the paint because it removes wax. I don't know if you can see how far I'm leaning back. I was pulling pretty hard. Okay, we're getting, hold on. I gotta get it lined up here. Pull it out.
Tell me when you want me to push.
Okay, push. Okay, there we go. We're over it. Okay, we're almost there. Almost there. Okay. You're right on it here. How's it look there?
It looks
Should it
awful
come-
close to the door. I think it should come
Come,
more.
come a little bit more. Oh, that was too much.
Okay.
I'll push back.
There. What do you think?
Well, how much gap is there? It's not. This other
much?
door's further this way, so how much?
Maybe this much.
Okay, I think you might have a little more gap than me. So just come a little teeny bit my way if we can. Just a teeny bit. Okay, let's see what that does. All right, let's lower it down.
Okay.
All right, we're just.
I'm just worried about this bottom part.
Is it
So
hitting?
well, no, it's not hitting yet, but
Well, let's start latching it and see what happens. You tell me what's going on.
clearing it. We cleared it, but it was looking like it was gonna hit. Oh, we've got screwed up here. Big gap.
Whoa, big gap. That's because I've not done a continuous piece of rubber. Well, that sucks. Water's gonna get in there. It's too big of a gap.
Now it.
I'll put some caulking in there. I hate to say it, but that's what we'll do. All right, let's attach the, the shock absorber.
Okay. I got it.
This one's different than the other one. Okay, lift up. More. Right there. Okay, we're on. You can relax.
Okay. Want me to put a bolt on up here?
Sure. This one had a washer, that one didn't, as I recall.
Okay.
I'm gonna do it tight, and I'm just gonna back it off like a full turn, maybe. No, that's too much. Just a little bit.
My excuse to go in now?
Yep. And that is it. So I ended up with some gaps here because the rubber moves as you slide the door in. And this one's the worst. Should have just allowed for some extra there, right there. So that's not really acceptable. I hate to do it, but I'm going to put some black caulking in there because I don't want water getting in there. We're going to the Oregon coast. It rains, and it will run down the side of the bus and go inside. So the problem with doing that is that when I do the track next time, I will have to get it all out of there, and that sucks. So I don't got a better idea right now.